Hello to all my friends. In this video I'm going to quickly explain to you how does CFA model look like when you do it in IBM SPSS MOS. So IBM SPSS MOS used to conduct covariance based structural equation modeling CBSEM, wherein the first part is drawing a measurement model and assessment of that measurement model is done through CFA, that is confirmatory factor analysis. Now you have certain indices mentioned on a confirmatory factor analysis. When you do it, you get certain numbers. First we have to understand what do these numbers mean. Imagine these are your latent variables, unobserved variables known as latent variables. Three latent variables are there. Each latent variable has certain indicators which are observed variables. So say this is 1, this is 2, this is 3, and this is 4, depicted by rectangles, and each of them has a error term. Each of them has a error term attached to it. This is the unexplained variance or the measurement error. We call it measurement error or unexplained variance. There is one number which comes on top of this. This is squared multiple correlation, and there is one number which comes over here which is the standardized regression weight, or you can check the unstandardized regression weight as well. Unstandardized is represented in the form of units of measurement of your original items, and standardized is measured between 0 to 1. So this, the square of standardized regression weight, this standardized regression weight, when you square up, okay, you get squared multiple correlation. This squared multiple correlation tells you how much variance of that indicator is explained by the latent variable, how much variance, how much change in that indicator is represented by the latent variable which it is representing. So this is SMC, squared multiple correlation. And what is standardized regression weight? It is the relationship between the indicator and the latent variable, the strength and direction of relationship. You can call it like a correlation coefficient. So it is like a correlation coefficient which tells you the strength and direction of relationship between the indicator and the latent variable. Now this standardized regression weight, or we also call it standardized estimate, has to be at least 0.70, at least 0.70, because when you square this up it comes to somewhere around 0.50. Now why 0.50? 0.50 means at least 50% of the variance in the indicator is explained by this latent variable. So in this indicator 50% of the variance is explained by the latent variable. In case this standardized estimate is less than 0.70, then you have lesser amount of variance being explained by the latent variable. That means latent variable does not explain the true character in terms of the quantity which we require to be explained for an indicator. So that indicator becomes a valid indicator to represent this latent variable, because in reflective indicator measurement we are saying that all the indicators, these indicators are reflecting the nature of the latent variable which we want to measure, right? So these are effect indicators. These are not causal indicators, these are effect. That's why we call them reflective indicators. So now in this, one more thing which is important is you are co-varying all these together. When you are running a measurement model, you have to co-vary latent variable 1 with 2, 1 with 3, 2 with 3 as well, with double headed arrows, and then you run CFA, then you run confirmatory factor analysis. So the number which you get on these arrows are the covariances. When you standardize them, you get the correlation. So remember that standardization of covariance value gives you correlation value. Okay, so this was about the measurement model. Now if I talk about structural model, how does it look like? So in structural model, say you have two latent variables, each having three indicators. These are two independent variables, IVs. Okay, this is IV1 and this is IV2. Now you have a dependent variable, so you are saying that these two independent variables are predicting the dependent variable, right? So here you get beta. Beta is the standardized path coefficient. So beta, this tells you the path coefficient. Now it tells you the strength and direction of relationship, which we check through the significance value. We check the significance value of this path. If the p value is less than 0.05, we say the path is significant, otherwise it is insignificant. Here you get something which is known as R square value, right? Coefficient of determination, which tells you how much variance in the dependent variable is explained together by these independent variables. Listen once again. How much variance in the dependent variable is explained by the independent variables together is known as R square value. In this case, you have a error term on the dependent variable. This is known as prediction error. Prediction error. So when you are working with IBM SPSS AMOS, you have to draw a prediction error term on the dependent variable, because as the regression equation says, what is the regression equation? Y is equal to a plus bx. This is the predicted, right? Actual is y is equal to a plus bx plus e is the error term. This is the prediction error term, because none of this predicted value is exactly the actual value of the variable. This is just a prediction, so it must be having some errors. It will be having some errors. So when we account for the errors, we have to mark it on the dependent variable. That is the prediction error. As I told in my previous videos, a is the intercept, that is the minimum value of y when x is 0, and b is the slope. Slope means how much change in y happens on changing 1 unit of x. That is independent variable, right? So this becomes y is equal to a plus bx plus e. This error is the prediction error which you see over here, right? And again you have the factor loadings over here. You have the factor loadings. These are beta coefficients, path coefficients. This is R square value. So this is how you conduct a structural model assessment, and what do these values mean, right? I hope the session was informative and useful for you, and you will definitely share it with your friends and faculty colleagues. Thanks a lot.